Lewis Howard Latimer. Lewis Howard Latimer was an electrical engineer and inventor who made critical improvements to early electric lighting technology. He was born in 1848 in Chelsea, Massachusetts, to parents who had escaped slavery. Latimer's engineering career began as a draftsman at a patent law firm, where he taught himself mechanical drawing and became exceptionally skilled at translating inventors' ideas into precise technical drawings. He famously drafted the patent drawings for Alexander Graham Bell's telephone in 1876. His most significant contribution came while working with Hiram Maxim at the United States Electric Lighting Company, where he invented and patented a carbon filament for light bulbs in 1881. This design was superior to Edison's original bamboo filament because it lasted longer and was more cost-effective to manufacture. Latimer's carbon filament process involved encasing the filament in cardboard, which prevented the carbon from breaking and extended the bulb's life significantly. He later joined Thomas Edison's company, becoming one of the Edison pioneers, a distinguished group of Edison's original employees. Beyond inventing, Latimer wrote the first comprehensive book on electric lighting, Incandescent Electric Lighting, a practical description of the Edison system. His expertise in patent law and technical drafting made him an invaluable expert witness in numerous patent cases involving electrical inventions. Granville T. Woods. Granville T. Woods was an inventor and engineer who accumulated more than 50 patents during his lifetime, earning him the nickname the Black Edison. He was born in 1856 in Columbus, Ohio, and received limited formal education, but pursued learning through independent study and hands-on experience working on railroads and in machine shops. Woods established his own company, Woods Electric Company, in Cincinnati in 1884, making him one of the first Black Americans to own a technology company. His most important invention was the synchronous multiplex railway telegraph, patented in 1887, which allowed communication between moving trains and railway stations. This technology dramatically reduced railway accidents by enabling dispatchers to know the exact location of trains and communicate warnings about obstacles or other trains ahead. The system worked by transmitting telegraph messages through the railway tracks themselves while trains were in motion. Thomas Edison twice attempted to sue Woods for patent infringement, but lost both cases, after which he offered Woods a position at his company, which Woods declined. His other inventions included an improved air brake system, an automatic circuit breaker, an incubator for hatching chicken eggs, and various improvements to electrical systems and railway safety equipment. Woods sold many of his patents to major companies, including General Electric, Westinghouse, and American Bell Telephone Company, to fund his continued research and development work. Elijah McCoy. Elijah McCoy was a mechanical engineer whose automatic lubrication systems revolutionized industrial machinery maintenance. He was born in 1844 in Colchester, Ontario, Canada, to parents who had escaped slavery via the Underground Railroad. McCoy traveled to Scotland as a young man to study mechanical engineering, returning to the United States with exceptional technical training. Despite his qualifications, racial discrimination limited his employment opportunities, and he initially worked as a fireman and oiler on the Michigan Central Railroad. This position involved manually lubricating the train's moving parts, a process that required stopping the train frequently, wasting time and reducing efficiency. McCoy invented an automatic lubricating cup that dripped oil onto moving engine parts while the machinery was still in operation, eliminating the need for constant stops. His lubrication system, patented in 1872, consisted of a cup with a bottom valve that released measured amounts of oil at regular intervals. The invention was so effective that it became standard equipment on locomotives and factory machinery throughout North America. McCoy continued refining his designs and eventually held over 57 patents related to automatic lubrication systems. The phrase, "the real McCoy," is widely believed to have originated from P.U. Are chasers insisting on McCoy's authentic lubricating systems rather than inferior imitations? though this etymology is debated by some historians. Garrett Morgan. Garrett Morgan was an inventor and entrepreneur who created life-saving safety devices, including an early traffic signal and a breathing apparatus. He was born in 1877 in Paris, Kentucky, and moved to Cleveland, Ohio, as a teenager with only an elementary education. Morgan taught himself mechanics and worked as a sewing machine repairman before opening his own tailoring shop, and later a hair refining company. In 1914, he invented and patented a safety hood, a breathing device designed to protect firefighters and rescue workers from smoke and toxic fumes. The hood consisted of a canvas hood with an inlet tube that drew fresh air from ground level, where smoke concentration was lowest, and an exhaust tube for expelled breath. Morgan famously demonstrated the device's effectiveness during a 1916 tunnel explosion beneath Lake Erie in Cleveland, where he and his brother used the safety hood to rescue trapped workers from the smoke-filled tunnel. Despite the device's proven effectiveness, Morgan faced significant challenges marketing it to fire departments in the South because of his race, often hiring a white actor to pose as the inventor during demonstrations. His three-position traffic signal, patented in 1923, added a yellow caution light between the stop and go signals, improving upon earlier two-light systems and making intersections safer. Morgan sold the traffic signal patent to General Electric for $40,000. Frederick McKinley Jones. Frederick McKinley Jones was an inventor and engineer who revolutionized the refrigerated transportation industry. He was born in 1893 in Cincinnati, Ohio, and became an orphan at a young age. Leaving school after 6th grade, Jones was largely self-taught in mechanical and electrical engineering, gaining practical experience working in automobile garages and studying machinery independently. He served in World War I, where he developed expertise in electronics while working on communication systems. After the war, Jones invented numerous devices, including a ticket dispensing machine for movie theaters and equipment to adapt silent film projectors for sound. His most significant achievement came in 1938 when he invented a portable refrigeration system for trucks, allowing perishable food to be transported long distances without spoiling. The system was compact, durable, and could maintain consistent temperatures despite external weather conditions and rough road vibrations. Jones co-founded Thermo King Corporation with businessman Joseph Numero in 1940, and their refrigeration units transformed the food industry by enabling nationwide distribution of fresh produce, dairy, and meat. During World War II, the military used Thermo King units to preserve blood plasma, medicine, and food for troops overseas. Jones held over 60 patents in refrigeration, sound equipment, and other technologies. His work fundamentally changed American eating habits by making fresh food available year-round, regardless of growing seasons or geographic location. Otis Boykin. Otis Boykin was an electrical engineer whose innovations in resistor technology improved the reliability and precision of electronic devices. He was born in 1920 in Dallas, Texas, and earned a degree in mathematics from Fisk University, before working as a laboratory assistant testing automatic aircraft controls. Boykin later studied electrical engineering at Illinois Institute of Technology, but left before completing his master's degree to pursue independent research and invention. He established his own consulting firm and developed a wire precision resistor, patented in 1959, that could withstand extreme temperature changes and physical stress while maintaining accurate electrical resistance. This invention was particularly crucial for computer and missile guidance systems, where precision and reliability were essential. Boykin's improved electrical resistor design was used in guided missiles, IBM computers, and numerous other electronic applications. His most life-saving contribution was developing a control unit for pacemakers, making the devices more reliable and affordable. The resistor technology he created helped pacemakers maintain consistent electrical impulses to regulate heart rhythms, dramatically reducing device failures. Boykin held 26 patents, including innovations in televisions, radios, and computer components. His work focused on making electronic components more dependable and cost-effective, which expanded access to medical devices and advanced technology. Boykin died in 1982 from heart failure while working in his laboratory in Chicago, leaving a legacy of innovations that remain fundamental to modern electronics. Marie Van Britten Brown. Marie Van Britten Brown was an inventor who created the first home security system utilizing closed-circuit television technology. She was born in 1922 in Queens, New York, and worked as a nurse, often returning home at irregular hours to an empty house while her husband, an electronics technician, worked nights. Concerned about rising crime rates and slow police response times in her neighborhood during the 1960s, Brown invented a security system that allowed homeowners to monitor visitors and control access remotely. Her system, patented in 1969 alongside her husband Albert Brown, consisted of 4 peepholes at different heights in the front door, a camera that could slide up and down to look through each peephole, and a television monitor inside the home displaying the camera feed. The design included a 2-way microphone system enabling communication with visitors without opening the door, and a remote control mechanism to unlock the door from a safe distance. The system also featured an alarm button that could contact police immediately in emergencies. Brown's invention anticipated modern video surveillance and home security technology by decades, establishing the fundamental principles still used today. The patent influenced subsequent home security systems, door monitoring devices, and surveillance technology. Her design addressed specific safety concerns faced by urban residents, particularly women living alone or working non-traditional hours, by providing a method to verify visitors' identities before allowing entry. Mark Dean. Mark Dean is a computer engineer and inventor who played a fundamental role in developing the IBM personal computer. He was born in 1957 in Jefferson City, Tennessee, and demonstrated exceptional academic ability from an early age, earning a bachelor's degree from the University of Tennessee, a master's from Florida Atlantic University, and a PhD from Stanford University. All in engineering, Dean joined IBM in 1979 and was part of the team that developed the first IBM PC, released in 1981. He holds 3 of the original 9 patents for the IBM PC, including the patent for the industry standard architecture system bus, which allowed multiple components like printers, monitors, and modems to connect to personal computers. This architecture became the industry standard and enabled the PC's expandability and versatility. Dean also led the team that developed the first gigahertz processor chip, capable of performing 1 billion calculations per second, a significant milestone in computing speed. Throughout his career at IBM, he contributed to numerous innovations in computer architecture and held more than 20 patents. Dean served as IBM's first Black IBM Fellow, the company's highest technical honor, and later became a professor and administrator at the University of Tennessee. His work was essential in making personal computers accessible, affordable, and powerful enough for widespread adoption in homes and businesses, fundamentally shaping the digital revolution. Philip Emeagwali. Philip Emeagwali is a computer scientist and engineer, recognized for his pioneering work in parallel computing and supercomputer applications. He was born in 1954 in Akure, Nigeria, and showed exceptional mathematical ability as a child. Though his formal education was interrupted by the Nigerian Civil War, Emeagwali later earned degrees from universities in the United States, including a PhD in scientific computing. His groundbreaking achievement came in 1989 when he used a connection machine supercomputer with 65,536 processors working simultaneously to perform 3.1 billion calculations per second, setting a computational speed record at the time. This work demonstrated that complex scientific problems could be solved more efficiently by dividing them among thousands of processors working in parallel, rather than using traditional sequential processing. Emeagwali's calculations were specifically designed to help petroleum engineers detect underground oil reservoirs by modeling fluid flow through porous rock formations. The petroleum industry adopted his techniques to improve oil field discovery and extraction efficiency, significantly impacting global energy production. His approach to parallel processing influenced the development of the Internet's architecture, as data transmission across networks relies on similar principles of simultaneous communication. Through multiple pathways, Emeagwali has received numerous awards for his contributions to computing, including the Gordon Bell Prize. His work helped establish parallel processing as a standard approach for solving complex computational problems in fields ranging from weather forecasting to financial modeling. Lonnie Johnson. Lonnie Johnson is a nuclear engineer, inventor, and entrepreneur best known for creating the Super Soaker water gun, though his professional achievements span aerospace engineering to energy technology. He was born in 1949 in Mobile, Alabama, and demonstrated mechanical aptitude from childhood, building his own toys and robots. Johnson earned a bachelor's degree in mechanical engineering and a master's in nuclear engineering from Tuskegee University. He worked as an engineer for the United States Air Force and later joined NASA's Jet Propulsion Laboratory, where he contributed to spacecraft systems, including the Galileo mission to Jupiter and the Mars Observer Project. While working at NASA, Johnson experimented with a new type of heat pump in his bathroom that would use water instead of Freon, and during testing, a powerful stream of water shot across the room. Recognizing the potential for a powerful water gun, he developed the Super Soaker, which became one of the world's best-selling toys after its release in 1990. Generating over $1 billion in sales, Johnson used proceeds from the Super Soaker to fund his research company, Johnson Research and Development, focusing on energy technology. He has developed the Johnson Thermoelectric Energy Converter, a technology that converts heat directly into electricity, with potentially much higher efficiency than conventional methods. Johnson holds over 100 patents spanning toy design, spacecraft systems, and thermodynamic energy conversion, demonstrating remarkable versatility across engineering disciplines. Meredith Gourdine. Meredith Gourdine was an engineer and physicist who pioneered the field of electrogas dynamics, the study of converting gas energy into electrical power. He was born in 1929 in Newark, New Jersey, and excelled as both a scholar and athlete, competing as a long jumper in the 1952 Olympics and winning a silver medal. Gourdine earned a bachelor's degree in engineering from Cornell University and a PhD in engineering science from the California Institute of Technology. He worked at Caltech's Jet Propulsion Laboratory and later for aerospace companies before founding his own research company, Gordon Systems, in 1964. His primary focus was developing practical applications of electrogas dynamics, which involves using electrical fields to control the movement of electrically charged gas particles. This technology had applications in removing smoke from factory emissions, dispersing fog from airport runways, and generating electricity directly from combustion gases. Gourdine invented a device called the Incinerade, which used electrostatic precipitation to remove smoke particles from emissions, helping factories comply with clean air regulations. He also developed the Focus Flow heatsink, which used electrogas dynamic principles to cool computer chips more efficiently than conventional methods. Throughout his career, Gourdine held over 30 patents and founded multiple technology companies focused on energy conversion and environmental applications. His work demonstrated how fundamental physics research could be translated into practical solutions for industrial and environmental challenges, bridging theoretical science and commercial engineering applications. David Crosthwaite Jr. David Crosthwaite Jr. was a mechanical engineer specializing in heating, ventilation, and air conditioning systems, who designed climate control for some of America's most iconic buildings. He was born in 1898 in Nashville, Tennessee. and earned both his bachelor's and master's degrees in mechanical engineering from Purdue University. Crosthwaite spent his career at the C.A. Dunham Company in New York, where he became an expert in steam heating and air conditioning systems. His engineering work included designing the heating and cooling systems for Radio City Music Hall and Rockefeller Center in New York City, which required innovative solutions to control temperature and air quality in exceptionally large public spaces. These buildings presented unique challenges because of their size and the need to maintain comfortable conditions for thousands of occupants simultaneously. Crosthwaite developed advanced techniques for distributing heated or cooled air evenly throughout massive structures, ensuring consistent temperature and humidity levels. He held 39 United States patents and over 80 international patents for heating, cooling, and temperature regulation inventions. His innovations included improvements to vacuum pumps, boilers, heating systems, and temperature control devices. Crosthwaite also contributed to technical literature, authoring numerous research papers on thermodynamics and climate control engineering. He became a fellow of the American Society of Heating, Refrigerating, and Air Conditioning Engineers, one of the field's highest honors, and served on technical committees that established industry standards. His work enabled the construction of modern skyscrapers and large public venues by solving fundamental challenges in climate control engineering. Valerie Thomas. Valerie Thomas is a scientist and inventor who developed the illusion transmitter, a technology that creates three-dimensional optical illusions using concave mirrors. She was born in 1943 in Baltimore, Maryland, and developed an early interest in science despite limited encouragement, teaching herself electronics by reading her father's technical manuals. Thomas earned a degree in physics from Morgan State University and joined NASA in 1964, where she worked as a data analyst and later managed projects including the development of image processing systems. While attending a scientific seminar, Thomas observed an exhibit using concave mirrors to create the illusion of a glowing light bulb, even though the bulb was actually unlit. This sparked her interest in how mirrors could transmit realistic three-dimensional images. She researched flat mirrors versus concave mirrors and discovered that concave mirrors could produce optical illusions that appeared real and three-dimensional to observers. In 1980, Thomas patented the illusion transmitter, which used concave mirrors on both the transmitting and receiving ends to project 3D images. Unlike flat mirrors that reflect images as they are, concave mirrors invert reflected images, and when two concave mirrors are used in the system, the image appears right side up and three-dimensional to the viewer. The technology had potential applications in television screens, surgical displays, and video conferencing. Thomas's work influenced the development of modern 3D technology and visualization systems. She continued working at NASA until retiring in 1995, contributing to satellite technology and space observation programs throughout her career. Annie Easley. Annie Easley was a computer scientist, mathematician, and rocket scientist who worked for NASA for 34 years, contributing to numerous space programs and alternative energy research. She was born in 1933 in Birmingham, Alabama, during the height of segregation, and excelled academically. Despite limited educational opportunities for Black students, Easley attended Xavier University in New Orleans, studying pharmacy, but moved to Cleveland and found work at the National Advisory Committee for Aeronautics, NASA's predecessor, in 1955. She started as a human computer, performing complex mathematical calculations by hand before electronic computers became standard. As technology evolved, Easley learned computer programming languages including Fortran and developed software for analyzing alternative power sources, energy conversion systems, and battery technology. Her code contributed to the development of the Centaur upper stage rocket, which used liquid hydrogen and liquid oxygen as propellants, and launched numerous satellites and space probes. Easley also worked on projects examining solar power, wind energy, and batteries for hybrid vehicles, decades before these technologies became mainstream. Throughout her career, she faced discrimination but persisted, later advocating for equal employment opportunities within NASA. Easley returned to school while working full-time, earning a bachelor's degree in mathematics from Cleveland State University in 1977. She contributed to over 30 technical papers and presentations, and was recognized for helping identify energy alternatives and improving NASA's computational capabilities. Easley's work exemplified the critical but often unrecognized contributions of early computer programmers to space exploration. J. Ernest Wilkins, Jr. J. Ernest Wilkins, Jr. was a mathematician, nuclear engineer, and physicist who contributed to the Manhattan Project and made fundamental contributions to nuclear reactor design. He was born in 1923 in Chicago to a prominent family, and his exceptional intellect became apparent early when he entered the University of Chicago at age 13. Making him the youngest student ever admitted to that institution, Wilkins earned his bachelor's degree at age 16 and his PhD in mathematics at 19, focusing on differential geometry. He taught mathematics at Tuskegee Institute before joining the Manhattan Project during World War II, where he worked on nuclear reactors and radiation shielding. Wilkins conducted research on the absorption of gamma radiation, developing mathematical models that predicted how radiation penetrates different materials. This work was crucial for designing effective shielding to protect workers and equipment from dangerous radiation exposure. His calculations helped determine what materials and thicknesses were needed to block specific types of radiation, knowledge essential for both weapons development and peaceful nuclear energy applications. After the war, Wilkins worked in industry and academia, contributing to nuclear reactor development for power generation. He held positions at the American Optical Company, the Nuclear Development Corporation of America, and various universities. Wilkins published over 100 scientific papers covering topics in mathematics, physics, and engineering. He also worked on spacecraft radiation shielding, optics research, and mathematical modeling of physical systems. Despite his extraordinary achievements, Wilkins faced discrimination throughout his career because of his race, yet continued producing groundbreaking research across multiple scientific disciplines.